All right, we are going to look at a practice problem in circuit analysis using pretty basic circuits still, and our process of looking for ways to combine resistors as well as putting it all together, simplifying it so that we can solve the problem. So what is the current in this circuit, and specifically the current at the point of the battery? So as current is going to flow in this circuit, what is this current I? All right, so the first step in our process is to identify whether or not I have elements that can be combined. And remember, for us to think about elements being combined, we can use our pen as a tool to follow the path to see if whether or not my pen has to make any decisions before it goes through more than one element. So if I start here and I'm chasing my pen, I go through this first element and I have to make a decision. So this first element doesn't appear to be in series with anything. That being said, I have to make a decision, and so I have the possibility of maybe having something in parallel. All right. So let's follow this line here. I have my pen go through R4 and another decision point, another junction. So R4 may be in parallel with something within this other branch. Great, let's look at that other branch. As I go through this branch, my pen goes through R2 and then subsequently through R3. Aha! Those are two in series. So this process actually, to simplify this circuit from these 4 resistors down to a voltage source with a single resistor, which is the ideal, I can do multiple steps. So where do I begin? Well, first we're going to look for things as a strategy of everything in series. And so R1 we knew wasn't in series with anything. R4 is out there by ourselves, but R2 and R3 seem to be in series. My pen doesn't have to lift or make a decision as I go from one element to the next. So I can do a equivalent resistance in series, which is R2 plus R3. So R2 is 2 ohms. R3 is also 2 ohms. And so my equivalent resistance would be 4 ohms. So as part of the process, the next step is to draw a simplified circuit. So I'm going to redraw this circuit. Here's my 5 volts. I still have R1 in here. And now this is where my equivalent resistance, let's call this R equivalent A. Still have R4. Back to the battery. Okay, let me start the process all over again. Well, my pen comes out the battery, goes through R1, decision has to be made. So part of that current is going to go through R4. The other part of that current is going to go through my equivalent resistance, and nothing else happens before that current comes back together. And so these two are in parallel. So I can now analyze R equivalent A and R4 are in parallel. So let's analyze that. We know for parallel, the equivalence, and we'll call this equivalent B, is equal to the sum of the inverses of the 2, in this case 2, of the resistors in parallel. So R equivalent A plus 1 over R4. So if I solve for that, R equivalent A is 4, so I have 1 over 4 plus R4 is 1 over 1. I end up with 5 over 4 is 1 over my new equivalent, and so my equivalent resistance, B, is equal to 4/5 ohms. So I use that and I simplify my circuit. My 5 volts hasn't changed. I still have R1. Now I have R equivalent B, and I can complete my circuit. Then we restart the process. All right, take my pen, and I go out the battery, or go through R1. Before I have to do anything else back to the battery, I go through R equivalent. So R1 and R equivalent B are in series. So I'm going to analyze that. My R equivalent total is equal to R1 plus R equivalent B. R1 is 1 ohm. R equivalent B is 4/5 ohm. And so our equivalent is 9/5 ohms. And I can redraw my circuit. So I have 5 volts. And now I have a 9/5 ohm resistor. So this circuit with a 5-volt source and a resistor of 9/5 ohms is the same behavior as this circuit. How cool is that? All right, so I can solve my problem. Just give myself a little space. All right, so using Ohm's law, we know that the current is equal to the voltage over the resistance. So the current that I'm interested in, my voltage is 5 volts. My resistance is 9/5. And I get a current, 5 times 5 is 25, 9 amps. And if I kind of plug that into my handy dandy calculator, I mean, you can leave it like that, I suppose, but we get a amps of 2.78 amps for our current. All right. Process. Look for things that can be combined. Use your pen technique, your pen trick, to look for things in series and things in parallel, and do it one step at a time, reducing the circuit, reducing the circuit, reducing until it can't be reduced anymore, and solve for what we're interested in. Now, it's going to be the case that we aren't always going to be able to get down to a single battery and a single resistor. There are more complicated circuits than the ones that we've done in these last few examples. And that's a really fun process called Kirchhoff's rules, which is the next step in circuit analysis. Good job.